Hello, and welcome to the next latest and greatest webinar on CIS-210, Principles of Computer Programming 1 here at Georgia Military College. My name is Professor Lusby, and we are in week 3. Things are starting to get exciting. And I assume by now I'm going to have a very similar format to this webinar as the previous webinars. I really want to go over what it is exactly that we need to do for week 3 and provide some guidance there. A lot of you are finding this very useful, very helpful, and so I want to continue to do that. I assume everyone's familiar with the classroom by now. Obviously, all the links at the top. If you've missed any of the previous webinars, they are posted here. Obviously, uh, you should know the rest at this point. And if you have any questions, please email me. But the most important one here is this glorious virtual desktop. And I'm going to be demonstrating how to use that and NetBeans and Java uh, in order to accomplish our assignments this week, because that's what this class is all about, is learning Java. So without further ado, I do want to get us down here to week 3. Here we are. And week 3, if we look at the overviews and objectives, a little bit of a deeper dive, right, into object-oriented programming. We want to learn what these things called methods are inside of classes, and basically how to use them. And we want to learn how to create these objects that are created with these different class definitions, and how to do that as well. So for sure, we're getting into some fun stuff here. Here's our objectives. But at the end of the day, yeah, it's all about chapter 3, right? So in your textbook, the Java Illuminated version 5 textbook, you do want to make sure that you are comfortable with chapter 3. And we're going to start to talk about how we can use classes in our program, because up to this point we've been using a lot of primitive data types and inputting and outputting data, um, and that's definitely a good start. But there's a lot of really useful what's called classes that we can import and use into our program. And in particular, they call out a few of these here, right? There's this nice class called a string class that enables us to store string information and manipulate strings. So for sure, we're going to talk about that. There's a random class that can produce a random number for you. That's always a good thing, especially when you're producing video games. There's something called a scanner class that enables us to obtain input from the user, so we don't have to keep hard coding all of this input data into our program. We can actually ask for that input at runtime. Makes for a much more user-friendly program. And those are just a few of the high-level classes that we are going to learn about. For sure, your quiz will be over this information, so for sure, make sure that you go over this information and you study it and are comfortable with it before the quiz. All right, so what else? What else? Right. So we talked about chapter 3. We talked about the high-level overview and objectives. The supplemental resources, again, some students find this useful and helpful. Other students find it confusing. Again, if you find these links confusing or the information confusing, always come back to the textbook or email me. There are lots of other Java supplemental material that's online as well. But again, at the end of the day, if any of it starts going too far down the rabbit hole, or maybe it's just not a good resource, please, please, please always come back to the textbook. All right. So have a look at that. All right. What exactly do we need to do for this week? What is the graded material? All right. So the first thing is this week 3 discussion, and a lot of you have already started it, and that is really great news. And you've got a bunch of good posts. But basically, yeah, we want to look at programming activity 2 in chapter 3. And what that says is, so let's go to the book. Let's see what exactly this particular programming activity is here. And that's here in 316. In 316, okay, so programming activity 2 here in 316 wants us to write a short program um, using some of the classes and methods that are basically listed in this chapter that I just kind of pointed out to you, and it needs to meet these requirements here, right? Where section 1 is, um, give me just a sec. So yeah, section 1 is asking the user for their basically their first name, um, or prompting the user for their first name, printing a message saying hello to the user, telling the user how many characters are in their name. That's part 1. Part 2 is asking the user for the year of their birth. Notice both this prompting and asking requires the user to input things at runtime. And up to this point, we couldn't do that. But if we look in Unit 3, and I'm going to show you this in a second, there is a string class and a scanner class that we can use in order to obtain input from the user to meet these two criteria here. Calculate and print the age. Okay, there's some math involved there. Declare a constant, print a message that tells the user their expected life. And then finally, part 3, generate a random number between 1 and 20. Ask the user for a guess of what they think that number is, and then tell the user how far away they are from there. And this is the Java file that they give us that we can download and start with. Basically the same requirements that are listed up here. They just put them as comments down here, and that is definitely an excellent place to start. All right, so how do we go about completing this particular activity for the discussion? And again, I want you to make your best attempt at this, right? At least for me in the discussion, as long as you can make your best attempt and really speak intelligently about what it was that you found difficult, what it was that maybe an aha moment. Um, that's really what I want us to discuss. You don't necessarily have to get to the solution, but if you can get to the solution, that lets you know that, yeah, you're sitting pretty for this week's programming assignment. All right. So with that said, how do we go about finding the solution? We go into the nice, wonderful virtual desktop, right? Just like we always have for all previous programming assessments. We're going to go ahead and open up NetBeans, right? And your project's window on the left there may look a little bit different, but we need to do what we've always done, which is create a new project, right? File, new project. Make sure it's a Java application. Let's go ahead and click on next here. Let's give it a nice name, nice descriptive name. 23 already. What was the CIS-210 week 3 discussion? Right, nice descriptive name. Leave this as is, as the default path, please. Uncheck this. And here, go ahead and uncheck this because we're going to download what we need. So we do not need to create a main class. All right, so uncheck, uncheck, nice descriptive name, click on finish. And at this point, we don't have anything, and that's good. Nice empty project. So how do we get to, right, this file here that they provide for us, practicemethods.java? Aha, glad you asked. First, go into the virtual desktop and open up Chrome inside of the virtual desktop. All right, and I want you to click on this file here, CIS-210, excuse me, Programming Assignment Frameworks. And we are going to see a file that looks like this. All right, and we're going to go here into the source code. We're going to go into, I believe it is chapter 3. We're going to go down here into programming activity 2. Look at all this good code here. Okay, this is what we want. So for now, I'm going to minimize this. Excuse me. And we're going to pull that file explorer back up, and we're going to grab this Java file. I don't care about this class file. We're going to drag and drop, hold down that left mouse button, drag and drop it here into the default package. All right, now that we've got it here inside of our package, let's go ahead and double click on it, and we'll see that this is the file called out in the textbook. Has the requirements listed for us. We just need to convert all of these requirements into real code. So before this meeting, that is what I did. And so I basically went through that process I just showed you to create a new project, imported this file, practice methods. And this is what, at least one possible solution. Is this the solution? Is this the only solution? No. But for sure, let's go through this. Let's make sure that everyone understands why this solution is a solution. And hopefully it's going to introduce us to a bunch of really cool classes and code that we can use in the future. All right, first observation is there are going to be some libraries that we need to import, especially if we're using the scanner, especially if we're using the random guy, especially if we're using the nice decimal format class that we can make decimals nice and pretty with. And the way you know this is because, for instance, if I comment these out, you're going to see down below, all of a sudden, it's going to start to complain anytime that I'm trying to use classes. Well, these particular classes, right? For instance, scanner, and it's basically going to say, hey, I can't find this class called scanner. I have no idea what you're talking about. So you can do one of two things. One is you can double click on it and hit Alt Enter, and oosh, excuse me, please hold. Alt Enter, just hover over it and hit Alt Enter, and it will actually add import, right? And it will import the code for you, the library for you at the top. But this autocomplete stuff, I mean, look at how many options you have here, right? Where'd it go? How do you know which one of these to pick, right? I mean, what about these other packages here? You really don't. So what I would say is look in the book, in the textbook. They give some good examples of scanner, and we will see that. Where is it? Where is it? Where is it? Excuse me. Right here, it talks about the scanner class, talks about all of the methods available in the scanner class, and we'll talk about that in a second. But here it tells us, hey, you need to use this import statement in order to use those methods. And down below here is a great example utilizing the scanner, and also you see an example of the import statement at the top. All right, so anytime you see that error, undefined, whatever, more than likely there's an import statement at the top missing. All right, so that's what these import statements are, is additional classes that don't exist in the core Java JDK, or in the, we just have to import them before we can use them. All right. So that's what this is about. All right, let's look at this code down below here. This first line here, scanner, scan equal new scanner. Okay, so this is a new concept for us. Okay, up to this point, we've been creating primitive types. What was it? Int, float, character, maybe, Boolean. And when we do that, for instance, if we want to int, we just say int x equal to 0, right? And we literally give it a name. And this is a terrible name, by the way. And assignment operator, and we specify what it's equal to. Well, here all of a sudden, we're creating what's called an object. And the reason we know this is an object is a couple of reasons. Number one is there is this keyword here called new. And what new is doing is it's allocating memory for a new object of type scanner. So scanner is like a primitive data type, right? When we declare an integer, we are allocating memory for that integer. Same thing here, but this is a much more complex data type that has multiple pieces of information in it. that has multiple methods in it that we can use. And so when we want to create an object in memory, we have to pick a class, in this case scanner, and we have to tell the compiler to allocate the memory for it with this new keyword. All right. That's on the right-hand side. This is doing the memory allocation for us, kind of like the equal to 0. Remember that 0 is specifying what is going inside that variable. This is also specifying what exactly is going in the variable. And the name of the variable here is scan, right? What's on the left-hand side of this assignment operator is the actual name of the variable and the data type or the class type that is going to be stored inside of that variable. Note that this and this need to be the same, right? We can't just say int scans equal to a new scanner because this returns back a scanner object, right? So your data type in front of your variable name needs to match with the data type that is returned by what's called a constructor, the class constructor. All right, and we're going to see this pattern over and over again. Even if we look down here, where is it? Here, decimal format, right? Here's the constructor that creates the actual object with the new. Here is the variable that's going to store that object. And this variable is of the decimal format type, which is the same as the class that we're newing. All right. So this is key to object-oriented programming, is being able to create these objects using these nice custom classes. All right. And then even down here with random, right? We're newing it. Right here, this is creating the memory for it. We're putting it into a variable called rand, and rand is a random data type. This variable rand is the random object. All right. Okay, so we got to get really comfortable with that. More information in the book is, oh gosh. Let me find that. Give me a sec. More information on that is here in 3.2. And they kind of describe in detail what it is what this new operator is doing. All right, so that's in 3.2 if you need further information. All right, so now that we have this new scanner object called scan as the name of the object or the variable, scan, and you're going to see me use variable and object interchangeably. Technically, this is an object. A variable is one of the primitive data types, right? So anytime you find yourself using new and allocating memory, this is an object in memory. If you're using one of the primitive data types like int, double, float, you're going to reference those as a variable, not an object. All right. All right, let's go to line 25 here. It looks like we are printing, and we have some experience with this now, system.out. All right, fair enough. We're printing, enter your first name. Well, why in the heck are we printing that out? Look, part B here, right? Prompt the user for the first name. And not only that, this scanner, why are we creating the scanner? Part A, create a scanner to read from the keyboard. So this is meeting part A, this is meeting part B, and in line 26 here, string name equals scan.next. Well, what in the heck is scan.next? And if we look in the book, where'd it go? Please hold, let me find. So here in 3.10 of the book on page 123, and you can Google it too. I mean, this is a well-known class called Scanner in Java. These are some of the most popular methods in Scanner, but here's the one called Next that basically will read in the input that the user types in and return it as a string. Okay, so there's some more information on that. And so we can use, remember the scan object was created here on line 23. And if you didn't allocate memory for it, you would definitely get an error here. So for sure, right, just like a variable, we can't just say x equals 0. We have to say, well, int x, and then on the next line say x equals 0. Always make sure you're initializing your object, right? You're newing your object before you try to use one of its methods. And there are some caveats to that, but for the most part, that's what you always want to do. All right. So we're going to use the scan object to read in the next line of data. Why? Because it tells us to do that up here. Yeah, prompt the user for the first name. That basically means have the user enter their first name. And in line 27, print a message that says hello to the user. Well, that's exactly what we're doing here, hello. And we can use the concatenation operator along with the name that the user typed in at runtime. Line 28 says hello, your name has name, which is our string object called name. We can use its length method, which I believe, here's string class 3.7. I'm sure it lists a bunch of methods like here. All sorts of these nice, wonderful methods here in table 3.4. Length is one of them. All right, so you're going to notice when you become a programmer / software engineer, you're not going to know these methods off the top of your head, maybe a couple of them that you use a lot, but it's a lot of Googling, right? It's a lot of documentation. It's, well, look up this class, look up its methods. What do those methods do? What are the formats of those methods, right? What parameters do they take? What return values do they give? You know, you have to know all of that information in order to use the appropriate method with the appropriate parameters and the appropriate return value. And it might seem a little foreign right now. This is only week 3. And we're kind of using methods before we even know what methods really are. It just occurred to me, note to publisher. But just trust me, don't freak out if you see all these lists, right, of all these methods, and what, am I going to have to memorize all these? No, please. We can always refer back to documentation and look them up. And that's another reason why you want to use well-documented classes, right? You don't want to just download some random library that has some neat classes in it with zero documentation. You can, but you're going to take a risk by doing that. All right. So I hope everybody's comfortable here with these first 4 lines and how those map to A, B, C, and D, at least for part 2. All right, let's look at section 3 here. It says we'll skip a line and then prompt the user for the year they were born. Well, that's what that looks like it's doing. And then prompt, in what year were you born? And then on the next line, I guess it wants us to, this prompt basically means ask and input. So this is the input part where we're telling the scanner that we created up here, right, the scan guy, go out and read the next int or integer that the user types in. And we're using an integer here, right, because it's talking about the year that we were born. That's not going to be a float. I guess you could store it as a string, but we're going to do math on it soon, right? Because we've got some requirements up here wanting us to calculate and print the age. So for sure, we want year born to be an integer so that we can do math with it later on, not a string. All right, so that's why they're using next int here. And again, scanner has a bunch of different methods. One's called next, one's called next int. It just depends on the type of data that you want the user to enter. All right, so hopefully this part makes sense for part A and B here. Part C says, okay, calculate and print the age that the user is going to be. All right, well, in order to know the age, for sure we need to know what year they were born. But the second piece we need to know is, well, what year is it right now, right? Because your age is basically the year, current year, minus the year you were born. And obviously, this is a little bit off. I think we're in 2023 now. Somebody in 2050 is going to laugh at this. Um, and also note that this variable called this year, it's all caps. Why? Because this is a final. What the heck is a final? It is a constant variable. It is a variable that will never change. And I guess the assumption is that I don't know if I would declare this as a final, right? Because what if we run this program a year from now or 2 years from now? But it tells us, I think it says, yeah, declare a constant. Even down here, oh, that's for life expectancy. I don't know. This is need to be constant, but then I got to change the variable name. You know what? Fine, let's do it. Let's do it. I don't think this should be a constant because this year is relative to when this program is running. In fact, there is a method, current date method that we could use to obtain the current year without assuming it's 2023, and that would probably be a better solution here, but it's a little beyond the scope of this week. All right, and then this year you will be blah years old. So we used the math on line 48, and now we are letting the user know what that calculation was equal to. Let's see here. Calculate and print average life expectancy. Even this fluctuates. I always get bummed out when I see that. I thought we'd live to be 100 now, but maybe not. So here's the life expectancy. Again, they're declaring it as a final. I guess as a hard fact that life expectancy is 78. I think it's gone up since then. Maybe not. So again, they're going to declare this as a final, and that's fine. Use all caps. Here's the very specific value that will never change, baloney. And then on line 53, percent lived is your age, right, divided by life expectancy. So if you're 78.94 years old, well, that divided by 78.94 is 100. You basically lived 100% of your life, and that's how we calculate percentage, right? Current total divided by the max total. And then what they do is, because we'll see this in a second, when we step through this using the debugger, this particular decimal, this double, is going to have a lot of decimal points behind it. And maybe you don't want a lot of decimal points. Maybe you just want one, right? And that's what this decimal format class allows us to do, is to specify what exactly should that decimal look like how many places do you want? And you can get really fancy with this. If you look up the documentation for decimal format, let's see if it's even in each one of these classes is a rabbit hole in and of itself, with many, many different methods and parameters that can be used. We're just skimming the surface of all these different classes, of all these different methods. That's why if you're a software engineer, you better be good with documentation in Google, because it is constantly changing and there's all sorts of different, it's like Lego pieces, all sorts of different methods and classes that we can use in order to build a program, or we can even create our own classes. And we'll learn that towards the end of this course. All right. But in this particular case, fine, I think we just want one decimal place. So that's why we create this decimal format object called percent, right? And we use that object and call its format method. And when you call the format method, you have to pass in a percent, a parameter that lets you know, well, what percent are you wanting to display? And in our case, it is percent lib. That is the variable name. And if you do that, that should look nice and pretty, and we'll see that here in a second. And then part 4 here. So hopefully all of this, and again, is this the only solution? No, this is a solution. If you get the proper output, well, you found another solution. All right. Okay, and then question part 4 here, generate a secret random integer between 1 and 20. Well, that's what this nice, wonderful random class does, right? We create a new random object using that random class, and we assign it to this rand uh, object variable. Once we have the rand object, well now, once we have the rand object, let's call its next int method. Let's pass in the proper, I think this is like the max value. What does it say? 20 minus 10 plus 1. Well, that's 11 plus 1. This math, this is a little bit strange. I would assume this would just be 20. I don't know why they're saying minus 10. And I would have to look up the documentation for next int. Maybe let's do that here real quick. Give me a second. Yeah, so here's the documentation on random. They only really talk about next int, and there's other methods in random, but for sure this is what they're using. And here, if we want to generate a number from 1 to 6, well, we tell it 6 because that's our maximum value. But this next int will generate a value between 0 up to 6. That's why we have to add this 1. If you want to generate a random number from 1 to 6, you have to add 1 at the very end. So to me, we can do the same thing. Here, I think they're trying to do what we just saw a second ago, but they're trying to generate a number between 10 and 100. If you're going to do that, then maybe that's why this minus 10 is here, so you can go from 10 to 100. But this is just getting convoluted. I would replace all this with 90, right? And that'll generate a number between 10 and 100. So yeah, I want a number between 1 and 20. Therefore, I'm going to put 20 here. Let's not make things complicated. That's publisher. All right, line 70 here. Thinking of a number between 1 and 20, right? We're going to prompt the user. We're going to ask for their guess here on line 71, and then we're going to use our nice, wonderful scan object to read in the next integer. Why an integer? Well, we're asking them for a number between 1 and 20, therefore it should be an int. Once we have that integer stored in a variable called guess, an integer variable, then on line 74, right, we're going to say, all right, well, let's take whatever that secret number was and subtract it from whatever the user typed in as their guess. That's going to tell us how far away they were from the secret number. And then just in case it's negative, we're going to use this nice, wonderful math library. ABS stands for absolute value. So that'll help us drop off the negative just in case this answer here is negative, which it could be, right? If the secret number was 10 and we picked 15, well, it's going to be -5, and we don't want to show the negative. So we use this math. And this is called a static method. Notice how this is different. We're using a math class and a method inside the math class without using the new operator. We're not creating a new math object. So, and again, this is very niche. We'll talk about static methods later on. Just know that for now, if you want to use a math method, you can do so directly. You don't need a new math operator, a new math object. 75, let's print out the secret number. 76, let's tell them what the difference is. All right, so hopefully everybody sees how this code maps to this. And let's just run through it using the debugger here real quick. And let's make sure that it's behaving as we expect. And so I'm going to launch the debugger. I put a breakpoint here by clicking on the line number, and you see the red line. And I'm going to launch the debugger. You can either use this, or you can just right-click and say debug file. And we should see it stop here on line 23, and it does. And line 23, and let me move the variables window. I like putting it over here a little bit. What? I can't. There we go. Oh, where'd it go? Let me try that again. Please hold. There it was. Oh. Oh my gosh. All right, fine. Let's put it there. All right, so line 23, when I hit step over here, what I would expect to see is a new scan variable slash object here in memory called scan. Let's see if that happens. Let's step over. Here is scan. Notice it is a scanner data type, right? Using a scanner class. Notice this value is a little wonky, a little wacky, and you're definitely going to see that when you create objects in memory, right? When we created integers and simple data types, the value made sense. When you create an object in memory, notice that this object has all sorts of stuff inside of it. Look at this, all right? And these are all member variables of this particular scanner object and is what it needs under the hood in order to function properly. But the beautiful thing is we don't care. We don't need to know about any of this. It's called abstraction. We just need to know that we can create a scanner and call next whenever we need it. But it is kind of neat to see under the hood, right? All the different variables that are used with the scanner. And if the scanner starts acting wonky and maybe it's a custom class, then yeah, sometimes it does make sense to come in there and look at the contents of what's inside the scanner. But that don't worry about any of that. All right, we just verified we have a new object called scan in memory. That looks good. So then it jumps down here to line, what was that, 23, 24, 25. This is the next line of code. It says print, enter your first name. So when I click on step over here in the output window, I would expect to see, right, enter your first name. And we do. And then line 26 says, all right, use the scanner and read in the next string. So when I click on step over here, I would expect to be able to type something in here that the scanner is waiting on, right? So you're going to see when I hit step over here, it's going to kind of look like the scanner's, the debugger's hanging. Watch, right? It went away. There's no program counter anymore. Why? Because it's waiting for data down here for this next guy to return in the name. So I'm going to put Bob. And when I click enter, we'll see it. We should see the program counter go to line 27. And over here, we should see a variable called name or an object called name with Bob inside of it. All right, drum roll, please. I'm going to hit enter. All right, went to line 27. It grabbed that Bob, this next guy, grab Bob, and put it here inside of name. And we see that right here. Here's the variable called name that is a string with Bob inside of it. All right, then line 27 says, all right, print out hello plus name. Well, name is Bob, right? We can hover over it, or we can look over here, we see it's Bob. So I hit step over here, we should see hello Bob. Hello Bob. Let's see. Hello Bob. Excellent. Line 28 says, all right, now print your name has, name dot length. Well, what the heck do we expect to see here? Well, we would probably have to look up the length method in the documentation, but we would see in the documentation that it counts the number of characters inside of your string object, in this case, name. So in theory, it should return 1, 2, 3. And we should see your name has 3 letters. Drum roll. Your name has 3 letters. So all of this is behaving and acting as expected. Notice that the program counter jumped from 28 down to line 43 because that is the next line of code, right? All this stuff in between, notice is grayed out. These are all comments, right? So the computer completely ignores the comments and jumps down here to line 43. Line 43, calling a blank print line statement. I guess that is for here, part A, skip a line. So when I hit step over here, I would expect the output to skip a line. I just don't know if we're going to be able to tell just yet. And then 44 says, okay, print out in what year were you born. So when we step over this, in what year were you born? Makes sense. 45, okay, we're going to use the scanner again. And notice when I click on step over, right, program counter is going to go away. It's waiting basically for the user to type something in. So when I hit step over here, I would expect to see the program counter go away and it starts waiting for us to type something in. All right, goes away, waiting for us to type something in. I'm going to put a good year, bicentennial. Um, and at this point, when I click enter, I would expect to see the program counter go here to line 47, number one. Number two, put this value 1976 into year born. Let's see if that happens. Click on enter. And it just took 1976, put it into year born. We see that here in the variables window. So that looks good. Then 47 says, all right, let's create a variable called this year, assign it to the current year, 2023. Yeah, that's what we see this year, 2023. Line 48 says, all right, we'll take whatever's in 2023, in this case, 2023, in this year, which is 2023, subtract it from year born, which is 1976, and you'll see that this person is of a very young age. I think it's around 46-ish. And we should see that value populate into age. Let's see. 47. All right, so 47, right? Age, new variable in memory called age, set to 47. Perfect. So that looks good. Line 50 says, okay, let's output this year you will be 47 years old. All right, let's hit step over here. This year will be years old. Perfect. All right, then we get down here and it says, okay, let's create a new final variable called life expectancy. Set that to 78.94. So when I step over this, I would expect to see that over here in memory. We do. It is set to 78.94. 53 says, all right, take whatever that age was that was up there and divide it by whatever this life expectancy is, which is way too low, 78.94, and let's see what percent lived comes up with. Okay, 0.59, right? And we learned in math class that for a percentage, you just shift over the decimal by 2, and so that means that's 59.5%. But right now, if we display this to the user, maybe they don't know that, right? And they're going to look at this as a percent number and go, wow, that's less than 1%. That's nothing. No. This is 59.5%. So that's why we're using this decimal format guy. All right. So before we can use it, we have to allocate it, we have to new it, and we have to put it into this object variable called percent. So when I click step over here, I would expect to see a new object called percent over here that is a decimal format object. So I'm going to click on step over. Here's the new percent object that is a decimal format data type. And look, it's got all sorts of fun stuff inside of it. Do we need to know about any of this? No, but it's kind of fun to look at. All right, so I got this new percent object, and then on line 55, we're going to use that percent object and its format method to hopefully give us a nice, pretty percentage, which is based on whatever parameter we passed up here, and then put some strings around it. So far, you have lived whatever this nice, pretty percentage is of your expected lifespan. So I would expect to see that down here. I'm going to click on step over. Oh, notice that in the debugger, it recognized, wait a sec, I got to call this first before I know what in the heck to print out, right? And you'll see that a lot in the real world and in industry. Sometimes one line of code, and this is one line because look, the semicolon's here. They separated this one line of code into multiple lines, but really what this line of code looks like, I don't know if it's going to let me edit in the middle of this. I hope it does. And you should never do this, by the way. Never ever edit your code in the middle of a debug session. It's got to call this, right, before it knows what this entire string is to print out. So right now, I'm going to hit step over, and it may or may not jump down here to line 65 because there's a bunch of different stuff going on in here. There's this format method, and then there's print line. Let's see what happens here. Yeah, see, we're still here. It's still processing a bunch of this stuff in this line. So I'm going to click on step over one more time, and hopefully it's done processing this one line of code. Okay, good. And it is. Moral of the story is when you have a line of code like this with a lot of methods being used, right? We got this format method being used, we got this print line method being used. It makes debugging difficult. A better way to do this would be to break out this into its own statement up above this line of code, and maybe assign it to a variable, and then use that variable here. Maybe I'll show you that when we're done here. All right. All right, so that does what we expect. We got this nice so far you've lived only, that's baloney, of your expected lifespan. All right, then we get down here to line 65. All right, well, here is the random class. Notice that it's a class. We got to new it, and we got to put it into a variable. In this case, we call it rand. So I click step over here. I would expect to see rand over here, and we do. And it's got all sorts of fun stuff under the hood. Something called a seed. I'd love to talk about that, but that's not right now. And then we use this rand object in order to create this random number from 0 to 20, and we add 1 just so that we don't get 0. And so when I click on step over here, I would expect to see a new variable called secret with some random number between 1 to 20. Some random number between 1 to 20, and in this case, it's just 20. Doesn't seem very random, does it? All right, so secret is 20. Line 68 says, all right, print out. Here's your string, right? So I would expect to see that down here when I click on step over. I see it. Print out this string. What is your guess? That's your prompt. That's what you're asking the user to type in. So we see that down here. Now here, right, we step over here, it's going to look like it's going to hang because it's waiting for user input down here. So I'm going to click on step over. It hangs, waiting for user input. Let's say that I say the guess is 10. As soon as I hit enter, we should see it go to line 72, and this number 10 should go into this variable, right? Because this is going to return 10. 10 should go into guess, and we should see guess over here in memory. So let's see. Enter. Yep, there's guess set to the value 10, and we did move on to line 72. All right, 72 says, all right, take those two values, right? Secret, which is 20, guess, which is 10. We subtract the 2, well, that's 10. Find the absolute value of 10, which is just 10, and assign that to difference, this new variable called difference. So when we click step over, I would expect to see difference set to 10, and we do. And in 73, we should see the secret number was 20, printed out to the screen down here. Secret number is 20, excellent. And then finally, your guess was, and then difference is 10 away. We should see that down here. And then finally, we're at the end of main. We're at the last curly bracket of main. So when I click step over here, it should terminate the program. Right. So that is at least one possible solution to your discussion topic this week. Lots of new stuff going on with classes and objects. Notice how many variables, right, we had in memory running this program. So these programs are starting to get a little more complicated than just the programs that had 2 or 3 variables before it. And there was a lot of math in here, but we won't talk about that. All right, so that is for your discussion. I hope that helped. All right, what else do we need to do for this week? Week 3 programming assignment. Aha! Here it is, here it is. All right, write a program that is going to create a label for the records department. Right, this is back when, I guess, we used to file away information in file cabinets and put labels on all the folders, and boy, that was fun, wasn't it? I guess some people still do that. Ask the user to enter this information. There are these 7 pieces of information that we need to ask the user for. Then we should take that information and spit out a label or some output that looks like this, where last name is whatever value is put in here, first name is whatever about, right? You see these greater than, less than signs, replace that with the actual values that were entered for each one of those things. And for the date of birth, yeah, feel free to have the user enter their date of birth directly like that. You don't have to ask for their month and then day and then year and then create this nice pretty date of birth string. You can just say, hey, give me your date of birth in this format. Make life a little bit easier. So for example, here's what the output should look like after the user enters in all 7 of these pieces of information. Doesn't really specify what the name of this Java class or file should be. I've already gotten a couple of questions about that. I will definitely make note of that. I'd say, I guess, call it whatever you want. I'm going to call it week 3 for now. At least make sure it's a nice descriptive name. All right. How do we go about completing this? Well, first we go to our nice handy dandy remote desktop and we close our previous project, right? So we're not getting confused here. And let's go ahead and create, remember, a new project for every single one of these. Java application. We can't just open a file and start editing. What is this? 22, 23. WNCMP. 3. What is this? Programming. Let's just call it assignment. Oh, shush it. Talking on the computer. All right, week 3 assignment, leave that as default. Here, yeah, you may want to create a new class, right? Because we don't have any existing code. All these programming assignments do expect you to write code from scratch, but you can at least get a little bit of help here with NetBeans and have it create your main class for you. That looks like a good enough class name for me because the requirements don't tell us, right, what we should name it. So let's go ahead and click on finish here. And here is our nice, wonderful week 3 assignment, or at least the template it generated for us. And again, I do expect comments for full credit, but I like to get rid of the standard ones there. And this is how you're going to start out, right? So then the question is, all right, how do I go about finding a solution to this? And you always want to think of the IPO paradigm, and I've kind of done that for you here. I've got another guidance here, week 3 guidance. I did this before the class, right? I set up my project, did all this, and then in this file, I did this. All right. Here is some guidance for week 3. A lot of students who are new to programming are definitely overwhelmed with where to start with problems like this. Notice I use the IPO paradigm. What is the input? Get the input. Well, what do we need to do to the input? Create these nice strings that look like labels, and then we output whatever their names are, right? I will say this though, there is you do want, I'll give you one additional piece of information. Create a scanner object named, what are we going to call it? Scan that can input data from the user. Right, very similar to, where did our discussion go? Right here, we created a scanner here, and we used scanner a bunch of times here, somewhere down here. All right. So for sure you need a scanner, and you can call it whatever you want. I just like naming these so that, down here I can always reference back to a particular object or variable. And then I would basically say, use the scan object to help you read in the data below from the user. And notice that this data, right? First name, last name. Well, that sounds like a string to me. I guess most of these probably could be considered strings. Maybe zip code you might want to do as an integer in case you needed to sort these labels or addresses in numerical order if you wanted. But just keep that in mind when you're picking which method in Scanner to use here. Um, and then here, yeah, you want to use all your data gathered up here. And with string concatenation, right? And string concatenation means exactly what we did here, where we were, adding strings together or using the decimal format guide to format the string. But yeah, we want to use string concatenation and formatting to make sure that the output, at least for the first line, looks exactly like this. All right, you can't get creative. The company has told us the very top line of that label has to look exactly like this, where the last name is the actual user's last name and the first name is the actual user's first name. Same with the second line. The second line needs to look exactly like this, and the third line needs to look exactly like this. Those are the requirements. All right. And once you get these, uh, the string data stored, right, using, and these are just suggestions, string variable names like this, well, then go ahead and display or print them out to the console. All right. So the point of this assignment here is number one, that you can create objects that you need. Number two, you can use those objects to help gather data from the user. And number three, that you can do string formatting, right, in order to create very specific strings that are required. Um, right, and also notice I'm a little vague about what data types need to be used up here, and I want you to think about that as well. All right, and since there's no real math in this assignment, thank goodness. I didn't, like last week, I created a guidance example in order to demonstrate the math involved. That's not the case here, so I do not have another any further guidance than this for week 3. Okay, everyone should be able to come up with a solution using this, or if you have another, if you think you have another solution, that's fine too, as long as at the end of the day, right, your output looks like this. Well, let's just go back to the requirements. Your output looks like this, then I'm happy. All right. But in case you don't know where to get started, that's why this is here. All right. So that is your assignment for the week. And then finally, your quiz, of course, chapter 3 of your textbook, 7, 10 open response. Well, sorry, 7, 10 questions, 3 open response, and 2 3 open response questions. That's a typo. 3 open response questions, and then 25 minutes to take it. All right. So with that said, I think I'm up against the clock here, but I think that is enough information for week 3. Don't forget the results document, right? When you turn this in, not only do I need the code, the actual Java file, I do also need a results document that has the code copied and pasted, screenshots of it running, right? When we run, remember that output window we were looking at with the debugger? I need you to take a screenshot of the output window, and I need to be able to see this timestamp down here to make sure that you are running this, uh, today or now. Um, and what was the other thing? Yeah, and it should just be one screenshot because we don't have multiple flows here. It's just, hey, here's the user, enters in this data, and then here's what the output looks like. So yeah, you should only need one screenshot of this thing running in order to, for the results document, in order to verify the functionality. All right. Okay, so with that said, have a great rest of your week, and definitely reach out if you need anything at all. Continue to provide me feedback, like the video, leave a comment, whatever. Email me directly. That's what helps me make these webinars better. Okay, so have a great rest of your day.